Hi everyone, welcome back. In this session, we are going to learn pointers and arrays, which is one of the most important topics in C++. Many students feel pointers are difficult. Actually, pointers are not difficult, but they need clear understanding of memory. Arrays help us store multiple values, and pointers help us access memory directly. This session is very important for understanding pointers. Now let us understand computer memory. Computer memory is made up of many small memory locations. Each memory location has a value and a unique address. Just like house in a state, each house has a number. Similarly, memory locations have addresses. When we write int a equal to 10, the value 10 is stored in memory, and that memory location has an address. Variable does not store data directly. Variable stores data inside memory. These addresses are very important because pointers store addresses. So data stored in memory, memory identified by address, pointers store addresses. This is a foundation for pointers. Now let us define a pointer. A pointer is a variable that stores the memory address of another variable. Very important difference. Normal variable stores value, pointer variable stores address. Pointers are declared using asterisk symbol. Why do we need pointers? Because pointer allow indirect access to data, efficient memory usage, modification of original data. Instead of copying value again and again, we pass only the address. So pointer is like a direction board telling that where the data is stored in memory. Now let us see how to declare and initialize a pointer. Syntax: int asterisk ptr semicolon. This means ptr is a pointer. It can store address of another variable. Example: ptr equal to ampersand var semicolon. Now let us understand this program line by line slowly. First line, int var equal to 50. This creates a normal integer variable. Value 50 is stored in memory. Next line, int star ptr equal to ampersand var. Here ptr is a pointer variable. Ampersand var gives the address of var. That address is stored inside ptr. Now observe the print statements. Cout var, this prints the value of var, which is 50. Cout star ptr, here star ptr means go to the address stored in ptr, fetch the value from that address, so it again prints 50. So var shows direct access, star ptr shows indirect access. Both give same value, but access method is different. This is the basic working of pointers. But what if you want to both together? Without pointers, we need two separate functions. With pointers, we can return multiple values using pointer parameters. Now let us understand pointer to pointer. First, int val equal to 100, a normal variable is created. Next, int star ptr equal to ampersand val. Here pointer stores the address of val. Next, int double asterisk d underscore ptr equal to ampersand ptr. This is important. D underscore ptr stores address of ptr. Ptr stores address of val. Val stores value 100. So chain is d underscore ptr, then ptr, then val, then 100. Now printing. Val prints 100. Star ptr prints value at address of val, which is 100. Double asterisk d underscore ptr. First star goes to ptr, second star goes to val, then prints 100. So pointer to pointer means multiple level of indirection. This concept is used in dynamic memory, passing pointers to function, advanced data structures. Now let us see why pointers are important in functions. Normally a function can return only one value. Example, area function in this slide return area, perimeter function returns perimeter. But what if want to both together? Without pointer, we need two separate functions. With pointer, we can return multiple values using pointer parameter. Now observe the program. In the first program, one function return area, another function return perimeter. So two separate function calls are required. So now see the second program using pointer. Function pointers int asterisk area comma int asterisk peri, these are pointers. Inside function asterisk area equal to l into b, asterisk peri equal to 2 into l plus b. This means function directly modifies memory location of area and peri. So when control returns to main, area has calculated area, peri has calculated perimeter. So advantage of this are one function return multiple values. These are efficient. These are widely used in real project. This is very important exam concept. Now let us see type of pointers. First, null pointer used when pointer is not printing to any valid memory. Second, constant pointer. Pointer address cannot change but value can. Third, void pointer. It's a generic pointer, can point to any data type. Fourth one, dangling pointer. Pointer points to memory that is already freed. These pointers help in safety, flexibility, avoiding runtime errors. Always initialize pointer properly, otherwise program may crash. Now see examples. Null pointer is declared as like int asterisk ptr equal to null. Then constant pointers are declared int asterisk the const keyword, then ptr variable, pointer variable, which is equal to ampersand val semicolon. Like that, constant variables are declared. Then void pointer can point to int or float or any other data types, but must be typecast before dereferencing. Then dangling pointer occurs when memory is freed but pointer still refers. So dangerous pointer type should be avoided. A good programmers always set freed pointers to null, avoid dangling references. Now let us understand pointers arithmetic. Pointers can move forward, move backward in memory. When pointer increments, it jumps by size of data type, not by 1 byte. Example, int pointer jumps 4 byte, char pointer jumps 1 byte. So ptr plus plus does not mean next address, it means next integer location. This concept is very important in arrays. Pointer arithmetic allows array traversal, efficient looping, fast data access. Initially, PTR stores address of var, say let's say 65534. When you do PTR++, pointer does not increase by 1 byte. Instead, it is increased by size of the data type. Since int is 4 bytes, 65534 to 65538. Now, PTR equal to PTR minus 2. Pointer moves backward by 2 into 4, 8 bytes. So new address becomes 65538 minus 8 will be 68830. The important role here is pointer arithmetic depends on data type size. This concept is extremely important for arrays. Now let us move to arrays. Arrays are a collection of same data type elements stored in contiguous memory location. Index starts from 0. So the syntax for array is data type space array name within square bracket size of the array ended with the semicolon. Example, int a of array arr of 5 semicolon. So arrays are used when multiple values of same date, fixed data type, then fast access is required. Memory diagrams clearly shows contiguous memory location. There are three main operations on arrays: declaration and initialization, accessing elements, traversing arrays. Declaration allows memory accessing using index, traversing using loops. Arrays are simple but very powerful. There are three ways for declaring and initialization. Declaration only, memory allocated, values garbage. Initialization with values, compiler decides size automatically. Then partial initialization, remaining elements become 0. This is very useful in default setups. Here we have int my array of 3 equal to 1, 2, 3. So memory is allotted to for 3 integers. So accessing can be done my AR of 0 first element, my error of 2 is a third element. So modifying can be done, my error of 1 equal to 3, 25. Now second element changes from 2 to 25. So index starts from 0, access outside array size occurs error. Array access is very fast, always ensures index is within limits. Now let us see how to traverse array. Traversing means visiting each element one by one. First method using loop. Arrays is calculated using size of array variable by size of array of first position. Loops run from 0 to size minus 1 and prints each element. Second method, range based for loop. This is modern C++ feature. The advantage of this one is cleaner syntax, less error prone. Both methods are commonly asked in used in program. So arrays are classified as single dimensional, multi-dimensional. So under multi-dimensional we have two-dimensional arrays, three-dimensional array, n-dimensional arrays. So multi-dimensionals are used in matrices, images, game boards. One-dimensional array. It is used for linear data, example marks, salaries, temperature. It is accessed using indexed. So very easy and very frequently used array. This is the syntax for creating single dimensional array. Data type array name within square bracket size of an array. Example int numbers of size 5. So this is an example program for demonstrating one dimensional array. We have an array variable called num of num. Size is 5. So we can print any element of an array using the cout statement. Like num of 2 will print the 3. This is a third element. So this is a demonstration for two-dimensional array. Usually it is used in matrix representation. Syntax for declaring two-dimensional array. Data type, array name within square bracket, number of rows or size of the row, in another square bracket, number of column or size of column. This is an example. So it stores the data by means of rows and columns. So this example program demonstrates the matrix storage and also how to print the values of the matrix. So this slide explains very important relationship. Array name itself acts as a base address. Int asterisk p equal to a means p points to first element of an array. Asterisk p first element, asterisk p plus 1 is a second element. So internally a of I equal to asterisk a of I plus 1. So array internally use pointer arithmetic. This is a core C++ concept. So in this program, pointer p points to an array A. Using for loop, star p of I is used to access elements. So this access a of 0, a of 1, a of 2 and so on. So this proves entire array can be accessed using pointers. Array and pointers are tightly connected. This is frequently asked in practical scenarios. Pointers are used in dynamic memory allocation, arrays and strings, linked lists, trees, graphs. Without pointer, data structures are impossible. So pointers are the heart of C++ programming. So that's all for today's lecture. Please revise pointer basics, dereferencing, pointer arithmetic, array pointer relationship. So practice sample programs daily. So thank you. See you in the next session.